Hello, grade 12 students of the STEM strand. Um, this is our week 2 for general physics, and our topic for this video is kinematics in one dimension, an introduction. So, we learn later what's the meaning of kinematics in one dimension. We talk about motion. Motion is a part of our daily lives. We can even tell that most of the time, motion signifies life. Kung may nakita tayong gumagalaw, masasabi natin na may buhay. Hence, for this video, we try to introduce the study of motion. Of how and why there is motion is the subject called mechanics. Mechanics is a branch of general physics dealing with the intricacies of motion. So, mechanics has two branches, kinematics and dynamics. Kinematics describes how things move. So, how lang, paano gumagalaw. Dynamics sets to answer why things move as they do. So, kung bakit gumagalaw ang mga bagay, yun yung dynamics. So, pag-aaralan muna natin ang kinematics bago tayo pumunta sa dynamics. So, what are the three types of motion? You have translational motion, rotational motion, and general motion. So, ang translational motion is just motion that is dealing with the change of position with no spin or rotation. So, parang ang mga bagay-bagay, tinitignan mo lang sila as a particle. So, kung particle sila at kung saan sila lumipat, yun lang ang tinitingnan mo. You consider things like they are a particle na dapat maglumipat sila, nag-translate sila into a other position. Ganun pa rin yung itsura nila, hindi sila nag-spin. Ganun. Rotational motion naman ay yung motion lang na nag-spin, umiikot-ikot lang, pero hindi lumilipat. General motion is the combination of translational motion and rotational motion. So, for this video, pag-uusapan lang natin yung translational motion. Reference frames. Ano nga bang reference frames? With respect to describing motion, any measurement of position, distance, or speed must be made in lieu of a reference frame. Kasi, ginagawa natin ito para ma-describe natin yung motion. Motion kasi is subjective from the point of an observer. Parang ngayon, feeling mo hindi ka gumagalaw, nakaupo ka lang dyan sa harap ng phone mo, pero yung earth na kung saan nandun tayong lahat gumagalaw. So kung ang observer natin is from another from outside space, nakikita nila na ang earth ay gumagalaw. So ibig sabihin, pati ikaw na nandun sa loob ng earth gumagalaw. Medyo vague yung example. Pero ngayon na nakaupo ka, yung velocity mo is 0 meters per second, pero yung earth ay actually traveling around the sun. So you are traveling with it. So basically, pati ikaw nag-travel. Ganun yung reference frame. Kapag ang observer mo ay nandyan lang sa tabi mo, ikaw, hindi gumagalaw. Ang velocity mo ay 0 meters per second. Pero kapag nasa outside space, nasa outer space, gumagalaw ka. Siguro mas maintindihan natin dito sa next example. When a passenger moves in a moving bus, observers inside the bus see the moving passenger normally. Kung nasa loob ka ng bus at let's say yung conductor nag-move, di ba? Nakita mo lang siya na nag-move normally, na parang kung ano yung nangyari dun sa labas. So yung reference frame mo ay nandun ka sa loob ng bus. Pero kapag yung observer ay nandun sa labas ng bus, sa labas ng moving bus, nakikita nila na pwedeng mas mabilis or mas mabagal yung conductor na gumagalaw. Mas mabilis kung, for example, nakakotse sila at pasalubong sila sa inyo. Pasalubong sila sa inyo, ang kotse yung observer, tapos kayo nakabas. Mas mabilis yung makita niyang paggalaw ng konduktor. Mas mabagal kung sumasabay yung kotse nila sa paggalaw ng bus. So parang nagiging normal na rin pag ganun. And then pero ikaw na nandun sa loob ng bus, parang normal lang lahat yun sa inyo. So observations must be done with respect to reference frames. So subjective yon. So mangyari, the velocities of the passenger, bus, and observer all combine if an observation or measurement is made with respect to each other's reference frame. So, ganyan. Magaan yan. May sasagutan tayo sa next slide. Ito. You are riding a car moving at 25 meters per second towards south. So, sabihin natin, dito yung north. Dito yung south. So, yung car mo is moving towards that direction. Papunta sa south. And you are moving at 25 meters per second. Moving opposite your lane is a bus at 30 meters per second traveling north. So, yung bus naman na yon ay 30 meters per second. The bus conductor moves towards the end of the bus from the front at a speed of 1 meters per second. So, papuntang south din yung ating conductor. So 1 meter per second. How fast is the conductor as you perceive it? Ikaw na nasa bus. So, gaano kabilis yung sa tingin mo? Gaano kabilis sa tingin mo yung conductor? So, katulad ng sinabi ko kanina, kapag magkasalubong kayo, mas mabilis yung perception mo ng speed niya. Which means, mag-a-add kapag magkasalubong. Pero kung magkasabay kayo, parang mas mabagal yung speed niya. So, magsusubtract naman kung magkasabay. So, basically, i-add lang natin yung magkasalubong na speeds. So, magkasalubong yung 25 kanina. Tapos, 30. at sumasabay naman sa agos ng sumasabay naman sa agos mo yung conductor. So isusubtract natin yung what. So ito kasabay, ito sumasalubong. So basically ganyan lang kasimple. Kapag nasa iisang direction kayo, isang direction lang, pero kung magkaiba na yung directions, nasa relative velocity na yon, at hindi pa yun content ng video natin. Ng relative velocities ay mas madidiscuss kapag matatouch na natin yung two-dimensional motion. So one-dimensional motion lang kasi tayo ngayon. So yan. So kung i-add natin yan, this is 54 meters per second. So, kung sa isang direction, pag magkasulubong, ina-add ang velocities kasi as you perceive it, mas mabilis. Pero kung sumasabay, syempre parang mas mabagal siya para sa iyo. That's it. We move. So motion is actually change in position of an object over time. With respect to time. Observation is again made with respect to time. Motion in one dimension implies that an object is moving in a straight line. So diretsong line lang. Walang liko-liko. There are three key ideas that describe motion along a straight line: displacement, velocity, and acceleration. So isa-isahin natin yung mga yan. Simula tayo sa displacement. Displacement, it is the change in an object's position. It has magnitude and direction, and it is therefore a vector quantity. So, alam na natin ibig sabihin ng vector quantity. Meron siyang magnitude at direction. Displacement, known as change in x, is the distance from the final position to the initial position. So magsisimula lang tayo sa horizontal motion. Pag change in x, horizontal motion lang muna pag-aaralan natin. So basically, change in x is equal to the distance from the final position to the initial position. So final position minus initial position. Okay. Most of the time, ginagamit natin si x lang as final at si x sub 0 as initial. May mga ibang books din naman kasi na ganito yung pagkakasulat din. X sub 2 si final at x sub 1 si initial. Pero ang main na idea dito, kung 0 ito, malamang x sub 1 din ito. Mas mataas palagi si final, yung subscript niya, kaysa sa initial. So si final, mas mataas ang subscript niya kaysa sa initial. So huwag sana kayong malito. In this case, yung nandito sa ating slide, ay final position x lang minus initial position, which is x sub 0. So tandaan natin yung formula na ito, magagamit natin yan palagi. Velocity naman, it is the ratio of change of position. So hindi ito ratio, rate dapat yan. It is the rate of change of position. Gaano kabilis nag-change ang position. Velocity 2 is a vector quantity. So hindi ito ratio, that should be rate. Yan, rate. Velocity 2 is a vector quantity kasi magnitude and direction. So in symbols, this is change in x over change in t, where change in x is again our displacement and change in t is the change in time. So yan, since changes sila, pwede lang nating isulat ang velocity bilang differences from the final to initial observations. Pwede natin silang isulat ng ganyan. Tandaan natin kapag change, pwede natin silang isulat as differences from initial to final. So, yeah. Terms associated with velocity. Unang-una, we have instantaneous velocity. So, instantaneous velocity is the velocity of a moving body at a specific instance of time. So, instance yun, hindi instant. Specific instant. Pwede din. Specific instant of time. In symbols, instantaneous velocity or V subscript inst is equal to the limit as t approaches 0. So as time approaches 0 of change in x over change in t. So sa isang napakaliit na specific unit of time approaching 0 ay yung instantaneous velocity. Okay. Mas ma-appreciate natin sa instantaneous velocity pag andun na tayo sa part ng speed. So, average velocity is the total displacement of an object over an interval. So, yan lang yan. This definition with respect to the initial velocity and the final velocity in symbols will look like this. So, average velocity. Yan. Tignan ninyo, may bar siya dun sa taas. Kaya average velocity. Ay, yan lang. Ina-average mo lang yung initial. Tapos yung final divided by 2. Ang average velocity, actually, mas ma-appreciate natin kapag andun na tayo sa motion with constant acceleration. So, hindi pa nga natin na-meet yung acceleration. So, hindi pa natin ma-appreciate ito masyado. Pero tandaan na rin natin yung formula na yan, yung average velocity. Okay. So, kita na tayo ulit dito sa next, no? Ay, hindi. Sa speed pa pala. So, speed lang. However, relative to velocity is different. Yan na. Dinidistinguish natin ang pagkakaiba ng speed at velocity. Since this is a scalar quantity, speed is a scalar quantity as it only has magnitude but no direction. So, ang speed is just distance divided by time. So, ano nga bang pinagkaiba nila? Parang ganito. Let's say this is a particle, and yung particle na ito nag-travel siya at ganito yung track niya, ganyan yung track niya, at andun na dito yung initial na position niya. So this is x of 0, tapos this is yung final na position niya. With respect to speed, yung distance na na-cover nito ay kung ano yung dinaanan niyang track. So kung yan paliko-liko, yan yung overall na distance. Pero pag sinabi mong velocity, syempre displacement yon. Ibig sabihin, yung shortest na distance from the initial papunta dun sa initial position papunta dun sa point na yon, sa final position, yun lang yung pinapakailangan niya. Yun lang yung tamang term dito. Yun lang yung doon lang siya concerned. Yun, parang ganun. So, syempre, since paliko-liko ito, ang lalabas na speed mo ay syempre, mas mahaba yun. Tapos, i-divide mo sa parehas na unit of time. Mas mataas yung numerator, tapos yung denominator mo parehas. Ang lalabas na sagot ay mas malaki, mas mahaba yung dinaanan mo, mas mababa yung denominator, mas maliit yung lalabas na speed mo, pero yung distance mo, displacement mo, basta ewan, yun na yun. Velocity, yung straight na line. So, yan yung displacement mo. So, ang displacement yun I see change in x. So, ito si displacement. Si distance naman represented lang siya ng d. So, pag displacement, change in x, pero ang distance ay si d. So, yan din yung pinagkaiba nila. Sinabi mong speed, dito lang. Tapos, yung velocity ay napag-usapan natin sa previous na slide. Sana naintindihan niyo yung part na yun. Acceleration naman is just the change in velocity with respect to time. So, since change ulit siya, acceleration is equal to initial minus final. Pwede natin ulit i-represent yung terms natin ng ganyan. So, meron tayong sample problems. Yan. Pero bago tayo mag-solve, may important note muna tayo. Babalikan na lang natin itong problem na yan. Pero kung gusto nyo i-screenshot, i-screenshot ninyo. Ito ang important note natin. When solving word problems, it is important that we distinguish first what are given. So, first step, alamin ang given. Yan. Given muna. Remember also to standardize given variables. So, ina-standardize natin sila. Kung naalala natin yung lesson natin sa SI units, so dapat nilalagay muna natin sila sa SI units. So, since velocity lang naman tayo, ang importante lang naman ay kinematics in one dimension lang tayo. Ang important na units lang naman ay with respect to length. So, kung length ang pinag-uusapan, yung standard unit ay meters. Kapag time, standard unit ay seconds. Kapag yun lang yung kailangan natin since kinematics lang tayo. Hindi pa natin kailangan ng mass. Kapag mass nang pinag-uusapan, pupunta na tayo sa forces at sa dynamics na part yun. So, kinematics lang. So, length at time lang. Length at time lang sa kinematics. So, meters for length at seconds for time. So, kino-convert muna natin yung mga yan sa units of length na meters at units of time na seconds. So, yun yan. Pagkatapos ng given, na-standardize na rin natin, tatanungin natin sarili natin, alam ba natin kung anong kailangan natin hanapin? So, know what is asked. And then, kapag alam natin kung anong hinahanap natin, maganda na nakagawa tayo ng diagram. Kasi mas maganda kapag gumagawa tayo ng diagram, mas naiintindihan natin. It helps us visualize the problem better. The next step will be to determine the right formula to be used. Ano yung note natin kapag i-determine yung right formula? Sabi dito, note that the right formula often leaves you with just one unknown variable. So, isa lang yung hinahanap na variable. As all other variables can be seen from the given or can be derived. So, yan. Isa lang yung unknown na variable. At most of the time, yung unknown variable ay yung hinahanap mo. So, last step will be substitute and solve. Madali na lang yan. Remember to express your answer in standard units according to the number of significant figures in the given problem. So, yan. So, ito yung problem natin kanina. The position of runner as a function of time is plotted along the x-axis of coordinate system. During a 3-second interval, the position changes. So, from 50 meters, so ito yung initial natin. So, ang initial natin, ngayon iba yung ginamit. X sub 1 naman ang initial natin. Tapos yung final natin, 30.5. As shown in the figure in the right, pero nasa baba na siya. What was the runner's average velocity? So, tingnan muna natin. Ayan. So, ito yung ating diagram. Okay. So, from 50 to 30.5. So, ang pinapahanap lang naman ay average velocity. So, runner's average velocity. Okay, so runner's average velocity. Okay, so yan. Ito yung given natin. Tinake-note natin sila. Then, kung papansinin naman natin, standardize sila. 50 meters, 30.5 meters, tapos yung time with 3 seconds. So, velocity lang naman yung pinapahanap. So, alam natin that velocity is the change in x divided by change in time. Pero, we know also that displacement is x sub 2 minus x sub 1. So, kino-combine natin yung equation na yan para magawa natin ito. Okay. So, sabi dito, combining equations will be a crucial skill in solving word problems in physics. So, yan. Dito. So, x sub 2 minus x sub 1. We have 30.5 minus 50.0 meters divided by change in time. So, 3 seconds. Makuha natin ay negative 6.5 meters per second. Anong ibig sabihin ng negative na direction? Ay negative na result. So, ibig sabihin lang yan ay dahil ang movement natin is from the right papunta sa left. sinasabi niya lang yung direction. So most of the time ginagamit lang natin yung signs. Ginagamit natin yung sign to represent direction. Yan. It can be seen that the units are used in the substitution. This will remind you of the credibility of your answer. So, kahit sa mismong pag-substitute natin, nilalagay natin yung units. Kasi kung tama yung units na lumalabas, malamang tama din yung sagot natin. So, negative sign tells you what direction the runner is moving from right to left. Kaya, negative. So, siguro naisip ninyo, sir, average velocity yan. So, dapat ang formula ay yung formula dapat ay initial velocity plus initial velocity pala. So, initial velocity x v sub 0 plus final velocity divided by 2. Yung problema lang kasi dito, wala naman yung mga yan sa ating given. So, mali yung formula na ito. Hindi natin magagamit ito. So, wala naman itong mga to sa given natin. Next. How far can a cyclist travel in 2.5 hours along a straight road if our average velocity is 18 kilometers per hour? Yun lang. Ang units natin ay hindi standardized. Ginagawa natin, ini-standardize muna natin sila. So, gagawin natin sila with respect to velocity, meters per second. Tapos, with respect to time, seconds lang. So, gagawin muna natin silang ganyan. At, ito yung mangyayari. Okay? So, yung 18 kilometers per hour, i-convert natin. Most of the time, kapag nag-convert tayo ng 18 ng kilometers per hour to meters per second, minumultiply na lang natin siya ng 0.27. So, 18 times 0.27. Hindi ko alam kung ano yung magiging sagot niyan. Basically, malapit yan sa 5 meters per second. Kung gusto nyo mag-shortcut, yun lang, yung conversion factor natin. Multiply nyo lang yan, nag 0.27, magiging meters per second na yan. So, dito. Yan. 2.5 hours. Magiging 9,000 seconds. 1,018 kilometers per hour is 5 meters per second. So, ano naman yung formula? Based sa given, meron tayong formula na ito. So, kung formula na ito, papansinin natin, average velocity is equal to change in x over change in time. Meron tayong velocity, meron tayong time, at ito yung ating ask. Ito yung hinahanap natin. So, ang ginagawa natin, minamanipulate natin itong formula para ito lang yung lalabas on the left side of the equation. So, mangyari, pwede tayong mag-cross multiply. Itong change in time pupunta dito sa tabi ng ating velocity. So, pupunta siya doon. So, mangyari, we have average velocity times change in time will be equal to change in x. So, yan. Yan na yung ating formula. Na-isolate na natin yung change in x. So, anong ibig sabihin nito? Kapag mayroon tayong formula, una natin ginagawa, ina-isolate natin kung ano yung hinahanap. Solve na tayo. Yan lang. Substitute and solve. Substitute. Solve. Simple. 45,000 meters. Wow. Or, kung mas iintindihan natin. That is 45 kilometers. Yan, 45 kilometers. Pero standard units niya. So meters. Mas appropriate yun. Next. A car accelerates along a straight road from rest to 75 kilometers per hour in 5 seconds. What is the magnitude of its average acceleration? So, take note natin yung given. We have dito tayo. Ito yung given natin. Acceleration yung pinapahanap. Final, 75. Initial, 0. At ang elapsed time ay 5 seconds. Pansin ulit natin, kailangan natin mag-standardize ng terms. Standardize natin yung terms. Since 0 yon, 0 lang nang lalabas, hindi mo na kailangan standardize ito. Hindi na ito, hindi na ito i-standardize kasi kahit i-convert mo yan, 0 din lang. So, this is also equal to 0 meters per second. Yan. So, ito, 75 kilometers per hour. Multiply ka lang ng 0.27. Kung gusto mo mag-shortcut, yan, 20.8 meters per second. So, ano ulit yung formula na gagamitin natin? Yan. Dito na rin. So, yung ating formula ay ito. Average acceleration is equal to change in v over change in time. Pero alam natin na change in v is that changes from ng final tapos initial. Since nakuha natin lahat ng given, pwede natin substitute. Lalabas yung sagot. Okay. Next. Ito, magandang tanong. If the velocity of an object is 0, does it mean that the acceleration is 0? If the acceleration is 0, does it mean that the velocity is 0? Think of some examples. Challenge ko yan sa inyo. Bahala na kayong mag-isip niyan. Pero, ang sagot dyan, sa parehas na questions, A at B, ay hindi. So, isipin nyo kung bakit hindi. Hindi ibig sabihin na kung ang velocity mo ay 0, ang acceleration mo rin ay 0. Hindi lang ibig sabihin na kung ang acceleration mo ay 0, ang velocity mo ay 0. So, at yung mismong clue ay ito. Acceleration tells us how quickly the velocity changes, whereas velocity tells us how quickly the position changes. Yan yung mismong, ito ang mismong clue dyan. Yan, mismong clue. Pero, ang parehas na sagot dito sa A at B ay no. So, deceleration. Ano naman ang ibig sabihin ng deceleration? When an object is slowing down, nag-slow down siya, so yung velocity niya nag-change from fast to slow, karaniwan sinasabi natin that is decelerating. We have a deceleration whenever the magnitude of the velocity is decreasing. So, bumababa nga yung velocity. And then, ito yung importante dito, velocity and acceleration point in opposite directions. Kasi baka iniisip natin, ang direction ba ng velocity ay yung direction din ng acceleration? Nandun ba sila palagi? Magkatapat ba sila palagi? Hindi ganon. So, ang mangyari, kung dito yung direction ng velocity mo, at nag-decelerate ka, bumagal ka, yung acceleration mo, nag-point na siya sa opposite direction. So, acceleration mo, since bumagal ka, ay opposite na sa direction mo. Yan. Hindi ibig sabihin na kung nasaan ang direction ng velocity mo, andun din yung direction ng acceleration mo. Hindi yan laging ganyan. At most of the time, hindi yan ganyan. marami pang instances, pero nasa 2-dimensional kinematics tayo para mas maintindihan natin. Yan. So, an automobile is moving to the right along a straight highway. Then the driver puts on the brakes to slow down. So, the velocity of the car changed from 15 meters per second to 5 meters per second in 5 seconds. What was the car's average acceleration? So, take note natin yung mga given. We have final, tapos initial, at yung time-lapse ay 5 seconds. So, yan. Substitute ulit tayo. At ang lalabas na formula na gamitin natin ay ito. And then, papansin natin, ang sagot ay negative 2 meters per second squared. So, negative na acceleration. Ibig sabihin lang ng negative na acceleration ay yung ating velocity vector kung papunta sa right ay positive. Positive yan kasi umaandar pa rin naman. So, papunta sa right. Papunta pa rin siya sa kanan. Samantalang yung acceleration natin, since nag-point na siya, papunta sa left. Kasi nga, nag-decelerate yung ating bagay. Bumagal siya. Yung acceleration na ay nag-point na papunta dun sa left. Yun ang ibig sabihin ng negative 2 dun. Yung negative na part. So, yung next video natin is motion at constant acceleration. Still, this is on week 2. So, guys, thank you.